Hey, how are you? Today we are going to talk about confidence intervals for standard deviation. So here I go. The standard deviations of the breaking strengths of cables is given as 240 pounds. After a change was introduced in the manufacturing of these cables, the breaking strength of a sample of 8 cables showed a standard deviation of 300 pounds. Investigate the significance of the apparent increase in variability, okay, using significance levels of 0.05 and part A, part B is 0.01. Mhm. Solution. Test the significance of the increase in variability means that is standard deviation. Because standard deviation is a measure of the variability in a distribution, standard deviation of the cables at level of significance, alpha. This is level of significance. Let's work on the first case, which is alpha is equal to 0.05. This means find the confidence interval of sigma population standard deviation with alpha equal to 0.05 or C, which is confidence level, is equal to 1 minus alpha is 1 minus 0.05, which is 0.95. Okay, so let's find the confidence interval for sigma. Okay, so if I uh, move this a little bit up and create some space. Okay, so alpha is equal to 0.05. I'm doing part A first. That means C is equal to 1 minus alpha is 1 minus 0.05 is 0.95. Also, alpha by 2 is 0.05 divided by 2 is 0.025. And 1 minus alpha by 2 is 1 minus 0.025 is 0.975. Our sample size n is equal to 8. So degrees of freedom is n minus 1 is 8 minus 1 equal to 7. Okay. So chi-square distribution looks like this. Let me erase that and do a better one. Okay. Let us consider the chi-square distribution for degrees of freedom is equal to 7. Okay. So the two critical values of chi-square we need is this one, chi-square alpha by 1 minus alpha by 2, because this area is alpha by 2 area. And the other one we need is such that area to the right is alpha by 2. So this will be chi-square alpha by 2. And this one, if I write it correctly, is 1 minus alpha by 2. In other words, if I move this a little bit, this is chi-square 1 minus alpha by 2 is 0.975, and this is chi-square 0.025. Okay, so we need to use a table with degrees of freedom 7 to find these critical values. I have to use a chi-square table with df is equal to 7 to find chi-square 0.975 and chi-square 0.025. Okay. So this is 0. Alpha by 2 is 0.025 area in the left tail, and this area is also 0.025, and the area in the center is 1 minus alpha, or 0.95. Okay, so let's see if I have a table available. And this is the table I'm talking about. So I will stick with the first column where the degrees of freedom is 7 and 7, and we know we need chi-square 0.975 is 1.69, and so I draw a horizontal line through 7, vertical line through chi-square 0.975, get the value 1.69, and for chi-square 0.025, draw a line through 7, horizontal line, and a vertical line through 0.025, and that critical value is 16.013. So let me make a note of them. So from chi-square table with df equal to 7, that means I draw horizontal line through 7 and find chi-square 0.975 is equal to 1.69, and chi-square 0.025 is equal to 16.013. So these two critical values we need. And this one. Okay. Why do we need these two critical values? Because the 95% confidence interval for the standard deviation, I'll create some space and show it to you, the formula. So 95% confidence interval for sigma formula. It will be n minus 1 s square divided by chi-square 0.975 less than the whole thing on the square root. Okay. Less than sigma. So this is the lower boundary for the confidence interval for the standard deviation. And the upper boundary is n minus 1 times s square divided by chi-square 0.975. This is 0.975 and this one is chi-square. Made a mistake. This is 0.025. Okay. So if we plug in, so in the lower boundary, it is divided by chi-square 0.025, which is the right critical value, and upper one is divided by chi-square 0.975, which is this critical value. So we do that because chi-square 0.025 is much smaller than chi-square 0.975. So we'll divide by a larger number. You notice chi-square 0.025 is 16.013. So we're going to divide by a large number in the denominator for the lower boundary. And the chi-square 0.975 is a smaller number. And we'll divide by a smaller number to get the upper boundary. So this will work out to be square root n minus 1 is, we have 8 sample size, 8 minus 1 samples variance is 300 is the standard deviation. So square divided by chi-square 0.025 is 16.0013. That is the lower boundary, less than sigma, less than 8 minus 1 times 300 square divided by chi-square 0.975 is 1.69. Okay. So let's do our calculation with a calculator. I'm using a TI-84. So I'll first press second button on the top left. Then x square gives me the square root. Inside the square root, 7 multiplied by 300, which is the standard deviation. Do not forget to square it to get the variance. So 7 multiplied by 300, then x square button. And then that thing is divided by 16.013. Once we get the number, that's your standard deviation, the lower boundary for the 95% confidence interval for the standard deviation. Less than sigma, less than, again, second x square gives me the square root. Inside the square root, 7 times 300 x square divided by 1.69. And that value is 610.56. So with 95% confidence, Let me check if I did it correctly. Oh, okay. I made a small mistake. It should be, let me correct that. And then this is sample standard deviation was 240, not 300. 300, uh, because normally, okay, so it is, let's do it with 240, because normally it is 240 pounds standard deviation, and this is 240. So let's see how much we get. So why did I change from 300 to 240? 300 was found in a particular sample of size 8. Now, normal standard deviation is 240, as given in the first line of the problem statement. So again, to do the calculation correct, second x squared gives me the square root. Inside the square root, 7 times 240, and then square it by pressing the x square, divided by 16.013. And that is equal to 150.68. So this is 150.68. And this one is second x square gives me the square root 7 multiplied by 240 square divided by 1.69. And that is equal to 488.45. So with 95% confidence, we can state that the actual population standard deviation will fall between 150.68 and 488.45. So if a sample produces a standard deviation of 300 as given in the problem, of 300 as stated in the problem, it is within the 95% confidence interval. Confidence within the 95% confidence level. Thus, a sample standard deviation of 300 is not significant, is not significant at 0.05 level of significance. What does it mean? It means that 300 is not that, let me write it down, that a value of 300, that a value of 300 is not outside the 95% confidence interval range. Okay, so that's part A. Okay, so if I want to do part B, where the significance level, so if I move, okay, uh, investigate the significance of the apparent increase in variability using significance level. Part B is 0.01. So alpha is 0.01. So confidence level is 1 minus 0.01, which is 0.99 in this case. So let's do part B. So part B. Let me see if I can change the color of the ink to make it distinguishable. So, okay. Part B. So part B, alpha level of significance is 0.01. So C level, confidence level is 1 minus alpha is 1 minus 0.01 is 0.99. Similar to before, alpha by 2 is 0.01 by 2 is 0.005, and 1 minus alpha by 2 is 1 minus 0.005 is 0.995. So much like before, we'll find out the critical degrees of freedom is same as before. N minus 1 is 8 minus 1 is 7. So if I draw the picture, or chi-square distribution has always an extended tail on the right. So this area, much like before, area is alpha by 2 is equal to 0.005. And this area on the right will be also alpha by 2. Area is alpha by 2. So area in the center, all this area is the confidence level is 1 minus alpha. C is 0.99. Okay. So this chi-square critical value is chi-square 1 minus alpha by 2, because the area to the right of is 1, total area from which you are subtracting alpha by 2, and this one is just chi-square alpha by 2. So this is chi-square 1 minus alpha by 2 is 0.995, and this is chi-square 0.005. So again, we have to go to the table. Now we are again 7 degrees of freedom, chi-square 0.995. For 7 degrees of freedom, draw horizontal line through 7, vertical line through chi-square 0.995. They intersect at 0.989. This is the lower critical value. The upper critical value is chi-square 0.995. Okay. So 0.995 is the lower critical value, 7 degrees of freedom 0.989, and chi-square 0.005 is 7 degrees of freedom, 20.278. Again, draw a horizontal line through 7, a vertical line through 0.005. So chi-square alpha by 2 is this value, high value, and chi-square 1 minus alpha by 2 is this low value. So going back to the table, going back to the problem, blackboard, okay, we get chi-square 0.995 is equal to 0.989, and chi-square 0.005 is equal to 20.278. So again, the formula for the 99% confidence interval for the standard deviation is under square root n minus 1 ss square divided by this chi-square 0.005 less than sigma less than n minus 1 times s square divided by chi-square 0.995. Okay, so if I move this a little bit up, so again this will be inside the square root. N minus 1 is 8 minus 1, 7 times samples variance is, or standard deviation square is 240 square divided by chi-square 0.005 is 20.275 less than sigma less than square root of 8 minus 1 times 240 square. 240 is the sample standard deviation, and you square it, divided by chi-square 0.995 is 0.989. This is 0. Okay, so let's do the calculation, and if I may write this correctly so that there is no so 8 minus 1. Okay, so this is, we have, so under the square root, second x squared gives me the square root in my calculator. Inside the square root, 7 multiplied by 240, then I have to x square it, divided by 20.275. And that works out to 141.02 less than sigma less than second x square gives me the square root. Inside the square root, 7 multiplied by 240 x square divided by 0.989. And the answer for that is 638.5. So as you can see, let me create a space. So in this case, we can state with 99. So with 99% confidence, we can state that the actual population standard deviation will fall between 141.02 and 638.5. Hence, the standard deviation in the value of 300 is well inside the 99% confidence interval. Thus, at significance level, which is the opposite of confidence level of alpha equal to 0.01, we can say a value of 300 is not significant, of 300, sorry, is not significant. Because it is well possible to have a value of 300 at 99% confidence. Okay. This is the end of part B. Let me summarize a little bit what I did there, right? So we will work with part A only. So if I move up a little bit. So what I did was I first found out the critical values of chi-square when alpha is 0.05. When alpha is 0.05, sea level is 0.95, area in the center is 0.95, and the two critical values are chi-square 1 minus alpha by 2 on the left and chi-square alpha by 2 on the right. And these two values are 1.69 and 16.013. So we found the lower boundary for the standard deviation using the formula and the critical value, upper critical value, and we found the upper boundary for the standard deviation using the sample variance of 240 square and the lower critical value. And we found out that it is between, with 95% confidence, we can state that the actual population standard deviation is between 150.68 and 488.45. What does it mean? That means with 95% confidence, we can state that 300 is within that 95% confidence interval, and it is not outside the range of the 95% confidence interval. Okay, it means, okay, and we can say it is not, thus a sample standard deviation of 300 is not significant at 0.05. That means it does not fall outside the 95% confidence interval range. And we repeated the same thing for a 99% confidence interval or level of significance of 0.01. I stop here today. If you like this video, please give me a thumbs up. That motivates me to produce more videos, more useful videos just for you. Hey, if you do not like this video, give me thumbs down, because then I know I have to improve on my quality. I make lots of videos. Some of these are good, some of them are not so good. So please be honest and give me a good feedback. I really appreciate that. And please write me a small comment. I'd also appreciate that. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. And please do not forget to watch me tomorrow when I'll be back with another interesting situation. Thanks for watching. Take care. Have a nice day.